In this lecture, I'll give some examples from business of matrix multiplication. Let's consider that you have 4 business locations and you have various costs at these 4 locations. Let's say the first location is Valdez for purposes of discussion. Then you've got a store in Homer, you have a store in Kenai, you've got a store at Sterling. And in each of these you have to pay for electricity, gas, snow removal, and maybe you have to pay some rent. And so you can construct this matrix of various charges at these different locations. Now let's say that the cost goes up by 10%. All the costs at all locations go up by 10%. And I want to find these new cost matrices, these new charge matrices. Okay, what I can do is multiply C by 1.10, and this is the scalar multiplication. That's because all costs are increasing by the same amount. Remember, if I multiply by 10%, well, as a decimal 0.10x, then I get the increases. I might want to have that, and that would be fine if I wanted to show the exact dollar value of the increase for each of these charges at each location. I would just multiply by 0.10. But if I want the new charges completely, then I'd have to multiply by 1.10c, because you would have the new equals the old plus the increase. So the old would be determined by the 1. The 0.10 gives me the increase. If this was the other way, say you had everything decreasing by, say, 20%, then you would multiply by 0.80 times C to find the new values. And the reason this works is because in scalar multiplication, this number multiplies every single element. Multiplies a 50 to give me 55, multiplies a 200, give me 220, and it continues through the whole matrix. From down here, 9, gives me 9.7. That's pretty interesting. I think 1.1 times 9.7 is 9.9. And continuing right along, I think that is right, because 1.1 times 150 would be 150 plus 10% of that, which is 15, 165. Okay, type that one in right. So this, if all the costs increase or decrease by the same amount, you can use scalar multiplication to find the new matrix. Now in this case, I'm just going to show you what happens. I'm going to take a matrix that looks like the diagonal matrix, but instead of having ones in the diagonal, it's going to have different values. And I'm going to multiply this by that cost matrix that I had previously. Right. And now let's look at what happens. Remember, if I multiplied by the identity matrix, I would get the identical matrix back. I would get the same cost matrix with no changes. But here, I have different numbers along the diagonal. So I'm going to carry this out. I'll just do it by hand here. Okay, 1.1 and then all these zeros, multiplying that first column. It'll be 0 times 25, 0 times 6, 0 times 9. All I have is 1.1 times 50. That gives me 55. Okay. Then I move over to the second column. Again, zeros against the 160, the 200, and the 150. All I have is 1.1 times the amount 200, which is in row 1, and that will give me 220. Now moving over to the third column, I would have 1.1 times 350, which is 385. And then I've moved now to the fourth column. All those zeros, because of those, I can just disregard the 12, 7, and 110. There's 0 contribution. And I have 1.1 times 110, which would be 121. Okay. Now move to the second row. In the second row, all I have here is a 2, and it will multiply the 25. Then I have 0 times 200, 2 times 160, which gives me 320, and 0 from 20, 0 times 150. Continuing, 19 goes up to 38, and the 12 becomes 24. And now I'd have to do the same thing with the third. Because I only have an entry here at the 3, 3 location, only row 3 gets multiplied. So this would be 4.8, 16, what's 0.8 be? 12, and 5.6. And now for the fourth one, I have only an entry at the 4, 4 location, so only the fourth row gets multiplied, and actually it stays the same, 150, 300, and 110. Okay, now let's look and see what happened. 50. Remember, these were locations. Valdez, Homer, Kenai, and the last one was Sterling. So again, this is Valdez, Homer, Kenai, and Sterling. The first column was electricity, then gas and snow removal, and then rent. What happened was that all the costs at Valdez increased by 10%. All the costs at Homer doubled. All the costs at Kenai went down by 20%. And the cost at Sterling stayed the same. So in the previous example with scalar multiplication, if I multiply the entire matrix by one number, like say 1.1c, that makes all costs everywhere increase by 10%. But this arrangement where I put them down the diagonal, this means only entries in row 1 increase by 10%, only entries in row 2 increase by will double, only entries in row 3 decrease by 20%, and only and all the entries in row 4 stay the same. So this is the way to separate out different increases. But notice this is going by rows. Now I'm going to take the same matrices, but I'll do it in a different order. In other words, I'm going to post multiply by this matrix with entries only in the diagonal. And let's see what I get this time. Okay, so in the first case, I've got 50, 200, 350, 110 times this first column. And all it gets multiplied is the 50 times 1.1 because everything else is 0, so I get a 55. Now move to the second column. Take this row and go into the second column, and you'll see the 50 multiplies 0, but the 200 goes down on the 2. You get 400 here. Going to the third column, you have 350 times 0.8, which is 270, right? Yeah, I think that's right. Okay, and then if I take this and go on to the fourth column, the 50s multiplied by 0, the 200 multiplied by 0, the 350s multiplied by 0, the 110 is multiplied by 1, and I get 110. Now I can continue this on the second row. The second row you get 2.25 times 1.1, which is 27.5. Then 160 gets multiplied by 2. You get 320 here. And the 19.8 is what? 17.2. Okay, and then 12 is 1. And I think you can see what's going on here. 6 times 1.1 would be 6.6. 20 times 2 is 40, etc. So what happens is that you have the same location. Valdez, Homer, this was Kenai, and this was Sterling. And here was the electricity. Now I have gas, snow removal, and rent. Because I multiplied in this other direction, everything in column 1, all the electricity now increased by 10%. Gas doubled everywhere. The snow removal got cheaper. It was a decrease by 20% everywhere. And the fourth column, you have the rent stayed the same. Okay, same matrices, just multiplied in a different order, gave you very different results, but depending on the situation, the result would be valid one way or the other. Now you might say, is there a way to make each entry change separately? Like make the electricity in Homer only change by so much, the gas differently? No. These are your choices right now. Otherwise you'd have to go in and do it by hand. Okay, so what I covered here were a business example using three kinds of multiplication. One was scalar multiplication, which everything changes by the same amount. In the second case, I used matrix multiplication using a diagonal matrix, right? And the entries on the diagonal, if I pre-multiply, that means I multiply first by that diagonal matrix, then the rows will change. If I the same. If I post multiply by that diagonal matrix, then the entries in the columns will change.